Now we're going to revise the chain rule, the product rule, and the quotient rule when we're using them with exponential functions. So I've written out the three rules here. This is revision, so there's probably no need to write down everything, but pay attention to the different types of questions that I've put on the board here and the methods for completing them. Now we're going to differentiate all of these. Now, bear in mind some other tricks. If you've got a complex expression, you can simplify it a lot of the time, which makes your work easier when you come to differentiate it. So if you can simplify something to get it down to individual terms that can be differentiated one at a time, that's fantastic. You might even want to expand brackets, whatever looks the quickest and the easiest. Now, some of these questions can be done multiple ways. So if you do it a different way from somebody else, that's fine, but have a look at those different ways so you can see if you can spot a method that will be quick and unlikely to mess up. Now, this first one, I've got two different parts multiplied together. So I could actually use the product rule for this, but I think that will take me longer than if I just expand the brackets and make myself two terms and differentiate them one term at a time. So I'm going to do that. So for the first one, I'm going to start by rewriting what y is, not dy dx. I want to rewrite this and then I'll work with it and differentiate it. I need to square this, which means I'm doing x plus x, it'll be e to the power of 2x. And then I need to do e to the power of x times 1, and I'll get this. Now I'm ready to differentiate it, and I can do it one term at a time. Now, we're taking into account that you remember how to differentiate exponential functions. The basic one, when you differentiate it, you get itself, so that's very straightforward. But if you're differentiating e to the power of some function of x, something a little bit complicated up here in the index, then the rule says take what's up there in the index and differentiate that, bring it down the front, so in other words, bring f dash x out the front, and then rewrite everything you are given, in other words, e to the power of that function. So we're taking into account that you remember these rules, and now we're looking at how you can apply them in more tricky situations. So here, to differentiate this term, I need to differentiate the 2x and bring that down the front. That'll give me a 2 out the front, and I'll get e to the power of 2x, which is just the part I rewrite. This is so easy, it differentiates to become itself, and I'm finished. Now see, that was really just a two-line process, so it's going to be quite a lot quicker than using the product rule there, I think. For question 2, you could throw the traditional version of the chain rule at this, but I think it's quite time consuming. I would actually do this one in my head, and the way I would do it is to say, well, I need to differentiate what's up here in the index, bring that out the front, then rewrite the rest. So I can do that all in one step. And that's because 1 minus x squared to me is quite straightforward to differentiate. I bring the 2 down here, and I get minus 2x. So I'm going to write my minus 2x out, then rewrite everything I was given. And I'm finished. Very straightforward. Now, the traditional way of applying the chain rule is to say, replace anything that looks a bit nasty or a bit complicated with a u. So I could have done it like this, and I'm going to show you this alternate way in case this is your preferred way. I'm not saying you shouldn't do it, I just think it's a little bit slow. So if you can do it this way and get it right, fantastic. If not, have a look at this one. Let's let u equal the complicated part, the 1 minus x squared. Now we've changed our question into y is e to the power of u. Now we can very easily differentiate y with respect to u, because differentiating e to the power of something, you just get e to the power of that very same thing. But I also need to differentiate u with respect to x. Differentiating u with respect to x means look at u, find the xy parts in it and differentiate them. So that means differentiate this. So even in this process, I need to differentiate this part, which is what I did over there in my head anyway, and got my minus 2x. I would put that now here. Then we say dy dx is equal to dy du times du dx. Well, I've got dy du, and I've got du dx. I need to just multiply those two together. So we say dy dx is this times that. You can write them in either order, but I tend to like to write that first and then the index expression next. Now, I've just committed what might be a mistake here. And very often when people do this method, they finish here. What's wrong with it? Well, there's no u's in the question, is there? And I've gone ahead and written a u in. So if you're using this method, be really careful when you go to write your answer, don't put a u in it. Replace the u with what u really needs to be and put the 1 minus x squared. That's a little bit of a pitfall. You can also see that all of that writing takes a lot longer to set it out. For question 3, I've got some stuff in brackets raised to the power of 4. Now I don't really want to expand out the brackets here because doing to the power of 4 is going to be a hugely long process. So I actually just want to use the chain rule. Now again, I could do it the easy way, using a part of it in my head, or the slow, complicated other way. I'm going to do both to show you. Now what I would do is say, alright, I've got some stuff, a function here, raised to a power. So what I need to do is I need to bring the 4 out the front. When I differentiate, the 4 needs to come out there. Also, the differentiation of what's in the brackets has to come out the front. And if I differentiate everything in the brackets, I'm going to get 2 lots of e to the power of 2x. So I need that out there as well. Then I just rewrite everything that I was given in the brackets, but drop the power down by 1. That's the rule. Now I can rewrite it and say, well, that's actually 8 lots of e to the power of 2x. And I've got all of this still. Now, often I would think about what needs to come out the front and think I need my 4 out the front and I need my 2e to the 2x out the front. And in my head, I would actually just write down 8e to the 2x. So I would probably skip this line. And in fact, an examiner is going to be more than happy just with this one as long as it's correct. Now, how do you apply the traditional method of the chain rule? Well, you take the complicated part and you replace it with a u. So you say, let's let u be all this part in brackets that looks a bit nasty. Now what we've really got is y is equal to u to the power of 4. Now I can differentiate y with respect to u. I bring the 4 down the front and drop the power down by 1. And I can also differentiate u with respect to x. du dx is equal to, now I need to bring the power down, differentiate what's in the power here, and I'm going to have 2e to the 2x. Now I need to say dy dx is equal to dy du times du dx. So I need to multiply these two together. But there's a trick, isn't there? I need to be careful not to write down the u. When I get to the u part, I'll need to put in what u is equal to, because I've just put the u into the question. It's not by rights really in there. So I look at this and say, well, I've got all of that times all of that. Well, the 2 4s is 8. And I've got e to the power of 2x. And I've also got u cubed, but I'm not going to write u. I'm going to write all this stuff and cube that instead. Now see, we've got the exact same answer, but it probably just took a little bit longer. For question 4, I've got 2 parts of the function and they both have x's in them. So really I need to use the product rule here. There's no other choice. So define your parts. I actually write them down over on the side, almost like the ingredients of the recipe. Let's let u be the first part, and when we differentiate u, we get 3x squared. And let's let v be the second part, and when we differentiate that, we get itself. Now I can apply this formula, vu dash plus uv dash. And I can say dy dx is equal to, and I don't need to write that formula out, but I do find it useful to write down my ingredients. Stops you making a mistake. So I've got v times u dash, so I've got this times this. Now what to write first? It's up to you. I tend to like writing the basic numbers first, like the 3, and then the other 2 bits, it doesn't really matter too much. Let's write 3x squared e to the x. Then we need to add x cubed times e to the power of x. So we've got this, whoops, times, not plus. Now, there's our answer. You could express it like that, or you could actually factorize it and say, hey, these both have some things in common. They've both got e to the x in them, and they've actually both got at least an x squared in them. So that leaves me here with 3 plus x. And either of those answers are equally fine.